Hello everyone, myself Vinay Kumaram. I am actually pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. In my last video, I actually taught the 12th chapter of 8th standard mathematics. So this video is based on 13th chapter of 8th standard mathematics. So the 13th chapter of 8th standard mathematics is Introduction to Graphs. So you have already learnt about graphs in so many other videos which I have taught, and also in science subject when I was teaching the chapters which are there in science. There also I have explained so many key things which are required to understand a graph. So now in this particular video we will be understanding what is a line graph. So to understand what is line graph, we have to take certain examples to understand this. So when you have two variables and you are making a comparison between those two variables in a graph, then you will take one variable on x-axis and the other variable on y-axis and point the exact point where at a certain value of one particular variable you are actually locating what is the other variable is varying with respect to that particular variable which is there on x-axis. So that's why variable which we take on x-axis will be known as independent variable. So x-axis, let's say x-axis variable is there, so that particular variable will be independent. That means it doesn't depend on anything. And y-axis variable will be dependent. So this particular variable will be dependent on the x-axis variable, the other variable. How the other variable varies, dependent variable also varies. So that you should actually plot in a particular graph. And when you plot in a particular graph, you will get lot of questions just by looking at that graph. You should say so many things, or you should answer so many questions which can come in an example. So in graphical representation, when you actually represent a particular data set in a graph, then you can actually tell so many things which are actually involved in that particular graph. Because when you just have certain data points, and if you are not plotting that particular data points, you will not get what is the trend which is actually there behind these two variables. So when you actually plot a graph of those two variables on x and y axis, then you will actually get to know what is the trend behind those two variables, and you will get so many other information which is actually hidden behind that particular data. So we will take one example to understand this. So let's take time as one particular variable which is independent and temperature as other variable which is actually dependent. So now at different time in a day, how temperature varies, that we should actually go on looking at. So morning 6 a.m. in a day, temperature will be little bit lesser. So let's say 25 degrees Celsius is the temperature. So at morning 9 a.m. the temperature will be raised to 29 degrees Celsius. At 12 p.m. in the afternoon, the temperature will be raised to 33 degrees Celsius. And at 3 p.m. in the afternoon, the temperature will be somewhere around 32 degrees Celsius. And again in the evening 6 p.m. the temperature will be 28 degrees Celsius. So this is the variation of temperature along with the time in a day. Here time you should take on x-axis because this acts as independent variable, because time is not dependent on temperature. But temperature is dependent on time, because in morning times and in the evening times temperature will be less. But in the afternoon times temperature will be more. That you can notice in this particular variation of temperature. So that's why temperature is dependent on time, but time is not dependent on temperature. So that's why time acts as independent variable and temperature acts as dependent variable. So in this case we have to take time on x-axis and temperature on y-axis. So if this is y-axis, then this is x-axis. Here I am taking temperature on y-axis and time on x-axis. Now you have to set scale for this. If you go to my previous video where I have explained bar graph and line graph and pie chart, there I have explained how to scale a particular graph. Here also I'll just give a glimpse of it. So you should always see 1 unit on x-axis should be equal to a one constant value, and the same thing should be followed throughout the x-axis. For example, if you take first unit as 6 a.m. and second unit as 9 a.m., then third unit should be 12 p.m. only, because you can clearly see 3 hours gap is there in between these two units. So that means that particular scaling you should do on a particular axis. So after again, like the next unit will be 3 p.m. Here also you can see 3 hours difference is there, and after 3 p.m. it will be 6 p.m. So this is the time which I am taking on x-axis, and I am scaling that particular time constantly. So here also in temperature, first we will take some break, because always this particular point starts from 0. But here we have temperature starting from 25 degrees Celsius till 33 degrees Celsius. So we will just right away jump to 25 degrees Celsius, and from there we will actually go on scaling the graph. So from 25 degrees Celsius, I will next take 30 degrees Celsius, and I will next take 35 degrees Celsius, and next it will be 40 degrees Celsius. So this is the scaling which I am doing on y-axis, where the difference between each unit on y-axis is 5 degrees Celsius, and difference between each unit in x-axis is 3 hours gap. So now you should always remember there is a break point here also, and there is a break point here also, because the initial value starts from 0. The initial x value starts from 0 and the initial y value starts from 0. Since on x axis I am taking time cannot be 0, so that's why you don't bother about that. But on y axis temperature can start from 0, but here I want the temperature only in the range of 25 to 33. So that's why I have started from 25 degrees Celsius but maintained the constant scaling after 25 degrees Celsius. So I have showed the initial break point from this particular point, because you should not have a doubt that from 30 to 25, 5 degrees Celsius difference is there, but from 25 degree to 0, there is 25 degrees Celsius difference is there. It is not like that. So that's why here I have shown this particular break point, which actually defines that we have ignored that particular axis, like that much length of axis we have ignored and started from 25 degrees Celsius. And we have ended till 40 degrees Celsius because we want only up to 33 degrees Celsius in this particular example. So now, morning 6 a.m. the temperature was 25 degrees Celsius. So 6 a.m. So you can draw a perpendicular line from 6 a.m. and a perpendicular line from 25 degrees Celsius. Where these two lines meet, there is the point for this particular first data set, that is 6 a.m. and 25 degrees Celsius. Second data set is that 9 a.m. At 9 a.m. the temperature will be 29 degrees Celsius. So let us make 5 divisions in between 25 degrees Celsius and 30 degrees Celsius like this. So this first division is 25, this second division is 26, here 27, 28, 29. So just 1 point below 30 will be 29. So from here you can draw a perpendicular line, and from 9 a.m. you can draw a perpendicular line, and this point will be the second data point. So the third data point is 12 p.m. and 33 degrees Celsius. So 33 degrees Celsius will be in between 30 and 35. So if you take this as 30, this will be 31, 32, 33, 34, 35. So you can make 5 divisions in between 30 and 35, and the third division will be your 33 degrees Celsius, this one. So from here you can draw a perpendicular line, and from 12 p.m. also you can draw a perpendicular line like this, and this point where they will meet each other, so that is the third data point on this particular graph. And this 3 p.m. and 32 degrees Celsius will be your fourth data point. So 32 degrees Celsius is just behind 33 degrees Celsius. You can just draw a perpendicular line like this, and you can also draw a perpendicular line from this 3 p.m. and this will be your fourth data point. And 6 p.m. and 28 degrees Celsius is the fifth data point. So 6 p.m. is here, and 28 degrees Celsius is in between 25 and 30. So here this is 26, 27 and this is 28. So you can draw a perpendicular line from this 28 and also perpendicular line from this 6 p.m. and wherever they meet each other, that will be your fifth data point. So you can actually join these points, first and second, second and third, third and fourth, fourth and fifth. So now you can clearly see as the time progress till 12 p.m. the temperature was increasing in that particular day, and from 12 p.m. to 6 p.m. the temperature has got reduced. That means whenever sun is up at that particular time temperature goes on increasing, and whenever sun goes down and sets in the west, at that particular time temperature goes on decreasing. So this particular information you can actually easily see through this particular graph. So if I just give you data points, it will be difficult to notice, but if I give a graph like this, you can clearly see temperature is increasing and then decreasing. So this is how, and based on this particular graph you can get multiple questions as well, because there are a lot of information which you can decode from this particular graph. So when you have a graphical representation, you will get much more information, much more enhanced informations which you cannot actually identify when just the data set is there. So after plotting a graph, you will have a better idea about that particular data which is actually there or which is actually given to you. So after explaining about graphs, now we can go through certain examples which are given in your chapter in this particular textbook. So I'll be solving the exercise problems related to this particular concept so that you can understand these graphs better. So moving on to the next exercise which is there in this particular chapter, that is the first exercise, exercise 13.1. Coming to the first question in this particular exercise 13.1, there they have given a graph where the temperature of a patient is actually varying in between 35 degrees Celsius and 39 degrees Celsius in a certain amount of time. So every hour starting from 9 till 3, that is starting from 9 a.m. till 3 p.m., they have recorded the temperature of this particular patient, and this particular temperature is varying. So morning 9 a.m. the temperature was in between 35 and 36. You can notice this particular first data point, it is at morning 9 a.m. and this is in between 36 and 35, that is 35.5 degrees Celsius. So at 10 a.m. it was at 36, and at 11 a.m. it was at 39, and at 12 p.m. it was in between 38 and 39, and at 1 p.m. it was in between 36 and 37, and also at 2 p.m. it was between 36 and 37, and at 3 p.m. the temperature was at 37 degrees Celsius. This is how the patient body temperature was varied in 1 hour. So in the interval of 1 hour, they have recorded the temperature of the patient's body. So based on this particular graph, based on this particular data, they have given 5 questions in this particular first question, which you should go on answering. So coming to the A question in this particular first question. So what was the patient's temperature at 1 p.m.? So how much was the temperature of patient at 1 p.m.? You can clearly notice, you can draw a perpendicular line from this particular 1 p.m. So this point is for 1 p.m. and you can draw a perpendicular line from this 1 p.m. to y-axis as well. So that will be in between 36 and 37. So in between 36 and 37 means the answer will be 36 plus 37 divided by 2. That will be 36.5 degrees Celsius. So 36.5 degrees Celsius is the answer for A question. Coming to the B question in this particular first question, they have asked when was the temperature of patient's body was at 38.5 degrees Celsius. You can just draw a perpendicular line from 38.5 degree. 38.5 means it is in between 38 and 39. That is at this particular position. So you can draw a perpendicular line from this point, and you can see this particular point is actually matching with that particular 38.5 degrees Celsius. So now you can draw a perpendicular line on x-axis like this. So you can clearly see at 12 p.m. the patient's temperature, the patient's body temperature was 38.5 degrees Celsius. So the answer for this B question will be 12 p.m. So coming to the C question in this particular first question, there they have asked the patient's temperature was the same 2 times during the period given. What were those 2 times? So you can clearly see these 2 times were the times when the temperature of the patient's body was same. So that means at 1 p.m. and 2 p.m. So you can draw perpendicular line from these 2 points, and you can see at 1 p.m. and at 2 p.m. this particular patient's body temperature was same. Like that is 36.5 degrees Celsius. So the answer for this particular C question will be 1 p.m. and 2 p.m. So coming to the D question in this particular first question, there they have given what was the temperature at 1:30 p.m. How did you arrive at your answer? So that means you should explain how you are actually answering this particular question. So at 1:30 p.m. means it is in between 1 and 2. So here you can clearly see at 1 p.m. also the temperature, body temperature was same, and at 2 p.m. also the body temperature was same. So that means in between 1 p.m. and 2 p.m. the body temperature was 36.5 degrees Celsius. So here you can see, if I draw a perpendicular line from this point, it will be in between 36 and 37, that is 36.5. So even at 1 p.m. the body temperature was 36.5, and even at 2 p.m. body temperature was 36.5. In between it might have varied. It is not that it is not varied, but here we have limited data. That means here the data was collected only in the interval of 1 hour. They have not given intermediate data points, that is in between 1 and 2. So that's why, assuming this particular point, we are just assuming that patient's body temperature might be 36.5 degrees Celsius only. So 36.5 degrees Celsius is the answer for this D question. How did I come to this particular answer? Because I don't have any particular data given in between this 1 p.m. and 2 p.m. They have just given data for 1 hour interval. So assuming that 1 p.m. and 2 p.m. on this 2 time period, the temperature of patient's body was same. So in between that also it might be same. The temperature of patient's body might be same. So coming to this particular assumption, we are giving this particular answer, that is 36.5 degrees Celsius. Coming to the E question in this particular first question, there they have given during which periods did patient's temperature showed an upward trend. That means at what duration the temperature of patient's body was actually increasing. That means it was actually in the upward trend. So you can clearly see from morning 9 a.m. till afternoon 11 p.m. the temperature, like patient's body temperature, was in the uptrend. In between 9 a.m. and 11 a.m. it was showing upward trend. Here also you can see from 2 p.m. to 3 p.m. also there is an upward trend. So 2 p.m. and 3 p.m. So in between these time period, like 9 a.m. to 11 a.m. and 2 p.m. to 3 p.m., the patient's body temperature was in upward trend. As a reference, I have solved one particular question in this particular exercise 13.1. Similarly, you can solve similar other questions as well, because there they have given graph in each question. Just by looking at graph, you should go on answering, which is there in that particular exercise question. So in graph, this particular independent variables is also known as control variables. That means because this particular independent variables are not dependent on anything, they are controlled in a certain way. So that's why they are known as controlled variables, and dependent variables are actually dependent on this particular independent variables or controlled variables. This we have actually discussed. So now there is one more term which is known as linear graph. So what do you mean by linear graph? If a particular y-axis values is dependent on x-axis values, or so particular variable, that is dependent variable, is dependent on an independent variable, there it follows a certain trend. So when two variables are directly proportional to each other, and if they are linear in trend, that means in an equal interval of one particular independent variable, there is an equal interval of variation in the dependent variable as well. So that is actually given by linear graph. So here we will be learning what is a linear graph as well with an example. So let us take one example, quantity of petrol. So let us take quantity of petrol as one particular independent variable and cost of this particular petrol based on the quantity. That means cost depends on quantity of petrol, because how much more quantity of petrol you will buy, that much cost will increase, and how much less amount of petrol you will be buying, that much amount of cost will be reducing. This is how linearity is there in between quantity of petrol and cost. So let me give the data values here. So quantity of petrol, if it is 1 liter, then the cost will be 100 rupees. If the quantity of petrol is increased to 2 liter, then the cost will be 200 rupees. And if this particular petrol cost is 3 liters, then the cost will be 300 rupees. 4 liter is there, then it is 400 rupees. 5 liter is there, then it will be 500 rupees. So you can clearly see the difference between these two data points are 1 liter. So you can clearly see difference between 1 and 2 liter is 1 liter. Difference between 2 liter and 3 liter is also 1 liter. Difference between 3 liter and 4 liter is also 1 liter. Difference between 4 and 5 is also 1 liter. Here also you can see 100 rupees difference is there in between all these data points. So here you can clearly see there is an increasing trend in cost of this particular petrol. That means as quantity increases, cost is also increasing in a particular linear fashion. So that's why these kind of graphs will be linear graphs. So if we plot this graph, so let us take cost on y-axis. So let's say this is y-axis. So I'll be taking cost on y-axis, and this particular quantity will be on x-axis. So first unit will be 1 liter, second unit will be 2 liter, third unit will be 3 liter, fourth unit will be 4 liter, fifth unit will be 5 liter. So here also first unit will be 100 rupees, second unit will be 200, third unit will be 300, fourth one will be 400, fifth will be 500. So now if you go on plotting this particular graph, at 1 liter the cost is 100 rupees. So point will be here, and at 2 liter the cost will be 200 rupees. So the point will be here. So you can draw perpendicular line from y-axis and x-axis where they meet that particular data point. You should actually point on this particular graph. At 3 liter the cost is 300 rupees, and at 4 liter the cost is 400 rupees, and at 5 liter the cost is 500 rupees. So you can clearly see there is a linear trend. That means this particular graph is linearly increasing without any bending. So when you look at this previous graphs, there was actually difference between this particular line graph. Here the graph moved like this, then like this, then like this, and then like this. So there is no linear trend in this particular graph. Here one trend is there, here one trend is there, here one trend is there, and here one trend is there. So here in this particular graph you can clearly see this is linearly increasing without any variation. That means the difference between each data point is same throughout y-axis and throughout x-axis. So this particular graphs are linear graphs, and this is how you should actually express this particular data points. Based on this particular concept also, you have certain examples in textbook. You can go through that example so that you can actually easily solve this particular exercise questions. So coming to the next exercise which is there in this particular chapter, which is exercise 13.2. So in exercise 13.2, let us go to the first question which is there. Coming to the A question in this particular first question, there they have given number of apples as one particular variable and cost as other variable. Here number of apples are independent variable or the controlled variable which we are controlling. The number of apples is controlled, and the cost varies according to how many apples you are actually buying or how many apples you are actually considering. So here for one apple the cost will be 5 rupees, and for 2 apples the cost will be 10 rupees. For 3 it is 15, for 4 it is 20, and for 5 it is 25. So based on this particular data you should actually plot a graph. Here number of apples is a controlled variable and an independent variable. So that's why it will be there on x-axis and cost will be there on y-axis. So cost I am taking on y-axis, number of apples I am taking on x-axis. So here 1, 2, 3, 4, 5. So there is an increase in the number of apples. So 1 unit I will assign as 1. So the second unit will be 2. The third unit will be 3. Fourth unit will be 4, and fifth unit will be 5. So the difference between each unit is 1, 1, 1, 1. Because the difference between 1 and 2 is 1, difference between 2 and 3 is 1, difference between 3 and 4 is 1. So it goes on like this. This is how you should actually scale a particular axis. Here on y-axis also you should do a proper scaling. So 5, I am taking 1 unit on y-axis as 5 rupees, and the second unit will be 10 rupees because difference between 5 and 10 will be again 5. So the third unit will be 15 because difference between 15 and 10 will be again 5. So the fourth unit will be 20 and fifth unit will be 25. So here also you can clearly see there is 5 difference in each units. So this is how you should actually set a particular axis. So now when you buy one number of apple, it is 5 rupees. So the point will be here. And when you buy 2 apples, it will be 10 rupees. When you buy 3 apples, it will be 15 rupees. When you buy 4 apples, it will be 20. When you buy 5 apples, it will be 25. Here also you can clearly see there is a linear trend which this particular data points are obeying. That means number of apples and cost are the two variables which are linearly dependent on each other. or the cost of this particular apple is linearly dependent on the number of apples. Coming to the B question in this particular first question, here also they have given time and distance as two variables. Here time will be independent variable or the controlled variable, and distance will be dependent variable. So this is actually the time at which a particular car has traveled a particular distance in kilometer. So at morning 6 a.m. this particular car has covered 40 kilometer, and at 7 a.m. it has covered 80 kilometer, and at 8 a.m. it has covered 120 kilometer, and 9 a.m. it has covered 160 kilometer. That means in every 1 hour it is actually going on covering 40 kilometer constantly. So that's why this graph will also be a linear graph. So if we plot this particular graph, so here time will be there on x-axis and distance will be there on y-axis. So time will start from 6 a.m. and will give 1 hour difference in that particular scale on x-axis. So the next unit will be 7, next unit will be 8, and next unit will be 9. And then next unit will be 10. So we'll stop at 10 because here the time is given only up to 9. And distance which this particular car has covered is 40, 80, 120, 160. So while scaling, you should see through that equal difference should be there between units. So here 40 kilometer I am keeping as constant. So the second unit will be 80 because difference between 80 and 40 will be 40. And here third unit will be 120 because difference between 120 and 80 will be 40. And the fourth unit will be 160 kilometer distance. So now morning 6 a.m. that particular car has covered 40 kilometer, and morning 7 a.m. that particular car has covered 80 kilometer, and at 8 a.m. it has covered 120 kilometer, and 9 a.m. it has covered 160 kilometer. Here also you can clearly see the graph is linear. That means these two variables are linearly dependent on each other, or the distance covered by that car is linearly dependent on the time from 6 a.m. till 9 a.m. So again in this B question they have given two different questions. You should actually answer based on this particular data which they have given in this particular question. Coming to the first question in this particular B question, there they have given how much distance the car has covered during 7:30 a.m. to 8 a.m. Since this particular graph is a linear graph, it will follow a linear fashion which you can easily calculate. So 7:30 means from this particular point you can draw a perpendicular line like this, and from till 8 a.m. they have asked. So you should actually plot a perpendicular line from 8 a.m. Here in between 80 and 120 this particular point will be joining, and at 120 this particular point will be joining. So this particular distance you should actually calculate, that is in between 120 and 100. So what is 120 minus 100? 120 minus 100 will be 20 kilometer, because so at 7 a.m. it has covered 80 kilometer, and at 9 a.m. it has covered 120 kilometer. So at 7:30 it would have covered 100 kilometer. So from 100 kilometer to 120 kilometer, that is at 8 a.m. So what is the difference between 100 and 120? 20. So the answer for this first question will be 20 kilometer. So coming to the second question, here they have given what was the time when the car had covered a distance of 100 kilometers since its start. So at what particular time this car has covered 100 kilometer? So 100 kilometer is in between 80 and 120. So at 80 kilometer the time was 7 a.m. and at 8 a.m. it has covered 120. That means in between 7 a.m. and 8 a.m. it has covered 100 kilometer. So what is in between 7 a.m. and 8 a.m.? That is 7:30 a.m. So at 7:30 a.m. car has covered 100 kilometers. So 7:30 a.m. is the answer for second question in B question. So coming to the C question in this particular first question, there they have given deposit in rupees and how much interest you will get, like simple interest you will get on that particular deposit. So if you deposit 1000 rupees, the simple interest will be 80 rupees in 1 year. Similarly, if you deposit 2000 rupees, then the simple interest will be 160 rupees. If you deposit 3000 rupees, then the interest will be 240 rupees. If you deposit 4000, then the interest will be 320 rupees. And if you deposit 5000 rupees, then the interest will be 400 rupees. So this is the graph which you should actually plot. So here deposit is actually there on x-axis because deposit is controlled variable or independent variable. So because simple interest depend on the amount of deposit which you will be keeping as your deposit. So that's why simple interest will be dependent variable and deposit will be independent variable. So we'll take deposit on x-axis. So we'll start from 1000, 2000, 3000, 4000 and 5000. So this is the graph which we have to plot. So these values are deposit which is there on x-axis, and on y-axis I will be taking simple interest. So the first point will be 80, the second will be 160, the third will be 240, fourth will be 320, and fifth will be 400. So here also equal interval I have taken on x-axis and y-axis. So that is 80, 80, 80 on y-axis and 1000, 1000, 1000 on x-axis. So that's why it is 1000, 2000, 3000, 4000, 5000. There is 1000 difference. Here 80 rupees difference is there on y-axis. So this is how you should scale the graph. So when 1000 rupees you are keeping, then the simple interest will be 80. When you are keeping 2000, the simple interest will be 160. When you keep 3000, it will be 240. When you keep 4000, it will be 320. And when you keep 5000, it will be 400. So here also you can clearly see the graph is linear graph. So coming to the first question in this particular C question, there they have given, does the graph passes through origin? You can clearly see when 1000 rupees is the deposit, 80 rupees is the interest. When 0 rupees will be the deposit, then interest will be 0. That means this particular graph is actually passing through the origin. And it has to pass through the origin, because at 0 rupees deposit, 0 will be the interest. So the answer for this first question will be yes, it is actually passing through the origin. The graph is passing through the origin. Coming to the second question, there they have given, use the graph to find interest on 2500 rupees for 1 year. So coming to the particular second question, we know that at 2000 rupees the interest which we are getting is 160 rupees, and at 3000 rupees the interest which we are getting is 240 rupees. So at 2500 means this is in between 2000 and 3000, because 2000 plus 3000 divided by 2 will be 2500. Similarly, we have to add these two, 160 and 240, and we should divide that with 2. So 160 plus 240 divided by 2 will be 160 plus 240 will be 300, 400 will be there. So 400 divided by 2 will be 200. So the answer for this second question will be 200 rupees, because 160 plus 240 is 400, 400 divided by 2 is 200, because at 2000 you are getting 160 rupees and at 3000 you are getting 240 rupees. So in between 160 and 240 is 200, because in between 2000 and 3000 is 2500. So in between 160 and 240 will be 200. So 200 rupees is the simple interest at 2500 rupees. Now coming to the third question which they have given in this particular C question, there they have asked, to get an interest of rupees 280 per year, how much money should be deposited? So here you can clearly see at 240 rupees, so to get interest of 240 rupees, you should actually deposit 2000 rupees. So here you can clearly see, to get 240 rupees interest, you should actually deposit 3000 rupees, and to get 320 rupees of interest, you are actually depositing 4000 rupees. So now they are asking at 280 rupees, how much deposit we should actually keep. So 240 rupees we are actually taking, so these two are directly proportional. So at 240 rupees we are keeping 3000 rupees. To get 280 rupees as our simple interest, what will be the value? So now you can cross multiply this. So x into 240 is equal to 280 into 3000 will be there. So now you can bring this 240 to RHS. So x will be equal to 280 into 3000. So here you can clearly see in this particular slide, this is 3000. So 280 into 3000 divided by 240. So divided by 240 will be there. So here 0 0 gets cancelled with each other. So here 4 6 are 24, 4 7s are 28. Here 3 1s are 3, zeros are there, 3 2s are 6. So 2 1s are 2, 2 500s are 1000. So 500 into 7 will be 7 5s are 35. So 3500. So 3500 rupees you should actually keep as deposit to get 280 rupees as simple interest. So this much deposit you should actually keep to get 280 rupees as your simple interest. So 3500 is the answer for this third question in this particular C question. Coming to the second question in this particular exercise, there they have given two questions. So in that first question, they have given side of a square in centimeter. So side of a square they have given in centimeter. This is one particular variable, and perimeter is another variable in this particular question. So side of a square, when it is 2 centimeter, then perimeter will be 8 centimeter. When it is 3, then perimeter will be 12. When it is 3.5, perimeter will be 14. When it is 5, perimeter will be 20. When it will be 6, perimeter will be 24. So here you can clearly see at each 1 centimeter increase, there is a certain number of increase that is in linear fashion, because here you can see from 2 to 3 there is 1 centimeter difference. So what is the difference between perimeter? 4 centimeter is there. So from 3 to 3.5, 0.5 is there, but here you should see 0.5 centimeter, there is increase of 2 centimeter is there. So that means here when this particular 1 centimeter is reduced to 0.5, here also 4 centimeter is getting reduced to 2 centimeter. So when you are taking difference between 3.5 and 1.5, it will be 1.5 centimeter, and if you are taking difference between 14 and 20, it is 6 centimeter. So when you are taking 1.5, it is 6, and here also from 5 to 6, when you are considering, it is 1 centimeter. So 20 to 24 will be 4 centimeter. So here the side is actually increasing by 1 centimeter, 0.5 centimeter, 1.5 centimeter and 1 centimeter. And here perimeter is also increasing by 4 centimeter, 2 centimeter, 6 centimeter, 4 centimeter. That means whenever 1 centimeter increase is there, 4 centimeter increase is there in perimeter. Whenever 0.5 centimeter increase in there in side of the square, then 2 centimeter increase in there in perimeter. 1.5 is there, means it is 6 centimeter increase in perimeter. If it is 1 centimeter increase, then it is 4 centimeter. So that means here also some kind of linearity is there. That means whenever 1 centimeter increase is there inside, perimeter will accordingly increase. Whenever there is 0.5 centimeter increase, perimeter will accordingly increase. It is actually fixed value, because perimeter is the addition of all sides of that particular square. So if one particular side of a square is increasing, means all other sides should also increase by the same value. So the perimeter will also be increased by the same value. So here there is direct proportionality between the length of the square and the perimeter of the square. So there is a linear dependency between side of a square and the perimeter of that particular square. So first question, the answer for this first question and second question is yes. Yes, this particular data points are obeying linearity. That means this particular side of a square and perimeter is a linear graph. So if you want to cross verify, then you can actually plot a graph. You can take a graph sheet and you can actually plot this side of a square and perimeter, so that you will get an idea it is following a linear fashion. So coming to the second question, in this particular second question, there they have given side of a square and area of a square. Here you can clearly see the difference between 2 and 3 is 1 centimeter. That means when 2 centimeter area, side was there of a square, then area will be 4 centimeter square. When side of the square is 3, the area will be 9 centimeter square. When the side of that particular square is 4, then the area will be 16 centimeter square. So the difference between these numbers is 1, 1, 1. Here you can see difference between 2 and 3 is 1, difference between 3 and 4 is 1, difference between 4 and 5 is 1, difference between 5 and 6 is 1. That means constantly there is an increase of 1 centimeter. But here when you compare that with y-axis values, that is for area of this particular square, difference between 4 and 9 is 5, difference between 9 and 16 is 7, difference between 16 and 25 is 9, difference between 25 and 36 is 11. That means here there is no constant increase in this particular area. It is increasing in an other fashion. So that's why this particular area is not linearly dependent on side, because there is a constant increase in side, but there is no constant increase in area, because we are taking the square of that particular side. So that's why this particular graph will not obey linearity. So that's why this particular graph is not a linear graph. So area is not linearly dependent on side. Yes, of course, area is directly proportional with side, but not linearly dependent. So that's why this particular area is not linearly dependent on side. Hence, this is not a linear graph. So the answer will be no for this particular second question in second question. So this is all there in this particular video. I have explained this particular 13th chapter, that is Introduction to Graphs. And I have also explained exercise 13.1 and 13.2 and some examples. So some problems in 13.1 I have left for you to do, because it is just a simple plotting of graph. Like this, I will be uploading more physics, chemistry and mathematics videos starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel and stay tuned with my channel. Thank you.